Hija, ¿me pasas la computadora? Aquí está en el arriba del mueble. Ahí está. Es que aquí no, apenas en esta pantalla no se mira ni papas. Entonces, sí.
Yeah, just a minute.
Hija, ¿cómo se prende? No es que no tiene batería. Pásame, ahí tengo el cable de aquí, en la mochila.
Okay. Can you see that? Try to do it. Okay. And you're telling me which one will be right.
Number one is A.
Okay, number one. EA. Perfect.
Number two, C.
Ah,
Agreed.
this is your guy okay, right? Okay.
Number three has to be B because of
B.
because of second question.
Voted
Okay. Okay, that is the answer for the first one. Okay.
Number 4 is A.
I think number four is C.
Okay. Number four.
So for A, I don't think it has any relation with the diode. The bias battery voltage has nothing to do with the diode. Other than it needing to provide enough voltage to polarize it, correct?
Five is B.
I think number 5 is C.
If you didn't see I say anything, that means that's not the right answer.
Which is not the right answer for what question?
Right now we got number five.
Okay.
B as in boy.
So, Professor, this is a little bit illogical question for me, number five. We are just putting a DMM, so we are measuring something. We are not polarizing. So we cannot say that it's forward biased if we are just trying to determine what is the voltage on them.
That's only telling you when you connect a DMM high, okay, to the diode and the DMM low, okay, then normally that will be high. That means forward, it's not a reverse.
Right, so I would say if this screen of the DMM shows something positive and say
Right.
0.7
That's supposed
volts,
to be.
then Yes, it is forward bias.
Yeah,
Okay.
that means we don't care about whatever wrong with the diode.
Yeah, because if, for example, if we connect it like this and it shows us a negative, then it is reverse bias, so it's like,
So wouldn't that make it A or a reverse bias?
No,
I would say this question is not good in itself.
exactly.
It doesn't explain how it affected connected that way.
Basically, that's a question basically coming out from level.
Right, I've seen this in lab law. Thank you.
Number 6.
A.
A or C.
A
Yeah,
or
zero,
B,
one,
C,
A or
right,
C.
right.
Okay.
Seven is A.
Good.
Agreed.
C.
C for it, yes.
Last one is B.
Agreed. C.
So we were doing. I said B because that's what we were doing in class.
Right.
Rectification can be used for a lot of other things, right?
Maybe we not go up to that point. What does that mean for rectification? Okay, but the answer will be B.
Yeah.
Number 10, it has to be open. Because if it was short, it would be 0. If it was normal, it would be 0.7.
Number 10 is A.
Eleven.
11 is B.
Agreed.
Yeah, B.
Last one.
B. Number 11, B.
My answer is B.
For number 12, I say B.
Yeah.
I say
Num-
B.
Number 12.
But number 12 is B. Dot shot.
Now we are number 12.
Well, the diode is reverse biased.
So
Number
therefore, it is normal. It could be.
Number 12 is A. There's no
Well,
voltage.
yeah, you know what? I think A and C are actually equally good.
because it says 0 volts.
So I think number 12 could be A.
Perfect.
Right,
Huh?
Right, but also when the diode is normal and reverse polarized, it behaves as if it is open, right? So you can argue it's C also. The important thing is there's no current in this circuit
Yeah.
for
Very
whatever reason.
simple. You can say very simple. You can
Ye-
have a phone positive and a diode connect this way. Diode cannot be on. Right.
So, right. So it's opens. It's open.
Exactly. They open.
So Professor, should maybe answer C mean the diode is operating as directly polarized, right? Which is not. Okay, I get it.
Okay. That will be normally I given you the very short quiz. I try to see how many people can understand. Okay. If you still cannot, you better watch the video after the Zoom. Okay.
Sorry, did you say that we had to upload the quiz answers?
Yeah, every time when you get the Zoom, okay, after that, I will be loading into the video on. If you want to watch it, you go to the website, class website, click on the video.
Wait, so those are assignments?
What do you mean? Let's see.
No, I think colleagues are asking if there is some kind of a quiz that we need to upload these same answers that we just went over. You don't need to do that, right?
Yeah. Now, if you go into the class here, you go to the video. You see that?
Yes.
Okay, and you can click on that, you can watch again. Okay. Last time we already get up into this point. The diode, you know how the diode working, right? Okay. So this one we already done that. Okay. If you're looking on that example 3, okay. So the diode on or off.
The diode is off in this case. And that is because you have higher potential on on the cathode side and
Exactly. The thing is this is 8 volt and the other one only 5 volt. So diode will be open, off. Number 4.
Forward biased.
this is tricky question.
Forward bias. Okay, if you get confusing, okay, just bring a question. Now, what I tell you, this is an electronic technician. Basically, the handout we prepare for technician and also for engineering. Only thing is, we not go detail on design the circuitry. Okay. However, the theory will be good for either one. Okay. So when we go through the handout, some I will skip it. The thing is basically you don't need it. Something you have to know in order you can do your job. Okay. Today we're talking about Zener diode. Okay. This is a symbol for Zener diode. This is anode and basically anode here and cathode here. Okay. And you can see they're talking about breakdown. What that mean? That means they need this Zener diode. When the power connects into the circuitry, they want power only 5 volt. Higher than can damage to the circuit board. So that's why they have to get the Zener diode. When you go to buy the Zener diode, you have to telling them what voltage you want. 5 volt or 10 volt or 15 volt, any voltage. But you must let them know. Okay? Otherwise, they cannot do it for you. Okay? Now, a major application for Zener diode is a type of voltage regulator providing stable reference voltage for use in power supply, voltmeter, and other instruments. That means when you apply the power to the circuitry, I want only 10 volt, no more. So that's why I need the Zener diode. With the voltage is 10 volt. Any voltage higher than 10 volt, they break it down. That means you only get 10 volt. Okay? And that is a breakdown, and this is the voltage. When you buy it, they can telling you, okay, what voltage. Second thing, Zener can be working like normal diode. here. Now, if they working at normal diode, you can see the symbol will be look like here, and this point side positive and this is a negative. Okay. Now, you're looking at this circuitry. Zener here, 10 volt. Okay. So, try to understand the example. VG means 10 volt. What is V out if V in equal 20?
It's got to also be 10 volts.
Okay, you say they will be 10 volt, right? Okay, now I'm telling you. First thing, you have to supposed to be remove that one. No zener. What we out?
The
20
Zener
volts.
is shorted.
What I'm
And the-
saying is, we remove the zener diode. Question A, what we out?
20 volts.
20 volt. Okay, that will be 20 volt without zener diode.
Hey, Mr. Pham, question.
Yeah, go ahead.
I know it's 20 volts. The resistor, we can almost treat that like a short circuit. Is that correct?
Now the thing is, when you don't have any zener diode here, okay, and the output will be open,
Right, I got that.
so no current flow here.
Okay, all right, yeah, so no current flow, which means there's no voltage drop,
Exactly.
which means you're measuring the battery only.
Exactly.
Okay, got it.
Okay. If you question, go ahead and asking. Okay. Now, that is the first thing you have to do when you're working with a zener diode. So, if the V out here higher than 10 volt, okay, of the zener, so zener will be breakdown. Okay.
The output is going to be.
That means no matter what voltage here, 20, 30, output will be 10 volt. Okay. So the answer will be
would it be the
Except when the voltage goes lower, right?
so it'll be 10 volts?
the thing is in a breakdown. Any voltage higher than 10 volt, they will be get the zener voltage. So this is now will be 10 volt. And the next question will be the current through 220 ohm. That means the current here I equal 20 minus 10 to 20. Okay?
Yep.
Now, number C. Now, V in, okay? They can to 5 volt.
And not only 5, it says minus 5. -5, right?
Yeah, he's got -5 on number C.
But believe it or not, it's gonna be the same with -5 and +5 because it's just not enough for the diode to operate.
If you not say anything, that means the answer is not correct.
No, the answer is V out is -5 volts.
That's what I say. That answer is not correct. If I change
That-
V in equal 5 volt, okay?
With -5 volts, the diode is forward biased.
What do
So
you mean?
V out would be
They want what is V out?
For your
What-
resistor
minus
is
5
5
plus-
volts.
Yeah, it would be 5
Oh.
volts, wouldn't it? If
The
you
answer will be 5 volt.
because the 10 is higher than the 5.
Right. So it's 5 is not enough to reach 10. Right?
The main thing you want out of this, Mr. Pham, is to take the diode out first. Is that correct?
Okay.
And then after you
And
take the
you can do
diode,
the same thing. If no Gino. Right? No Gino here, then output equal 5. Correct?
So, right.
Okay. Gino breakdown or no?
There is no breakdown in this case.
Not breakdown, right?
No breakout.
Yeah,
not
no-
enough
no breakdown.
volts.
The thing is, they less than 10.
Right.
So they not break down, the answer will be 5 volt.
Right. And one question. So the Zener doesn't have the forward bias. We don't talk about that. It just doesn't work, right?
You cannot forward, this is round, this is 5 volt. No way. Open.
Right. Okay.
What is the current through 220 ohm?
In this case, it is 0 because there's no flow.
Exactly. The thing is, no current flow. You get input 5 volt, output 5 volt. Okay? Same potential.
But Professor, your question is asking about -5. Can
What
we
do you mean
talk about
-5?
that? Take a look at your question, number C.
Number C, 5 volt, it's not a -5.
I see a negative.
Okay. I see your question.
Yes,
Yeah, I misunderstand on here.
no problem. Let's talk about that. if we
Reading
can.
here, that's a -5, not 5. Sorry.
No problem.
so now do that one, Mr. Pham, -5.
Okay, I will do it.
Would V out be -4.3?
I think that has a chance to be.
If V in equal -5, what V out?
So we would have a chance for this diode to be directly polarized, right? question is, it should give a drop of 0.6, 0.7. What does it give?
You
Okay.
wanted to know V out. V out is -5 as well, right?
Maybe not. Maybe not.
Maybe not.
Maybe not.
Okay. If you get a -5 here, right?
Right.
Right.
What happened to the zener?
It is directly polarized.
Well, you took the zener out, right?
No, it's still there.
I thought he said when you first start off, you take the zener out and then find V out.
Right.
You know what?
You get a -5. Okay. If no zener. However, now you get a zener.
Oh, now you got the zener.
You know what? I think that we need to talk about that for a little bit. When Professor says you take the diode out, I think what he means is try to assume that it is not working.
Exactly.
So then you are kind of operating under that presumption it is not working. But if the conditions in the circuit give you clearly that they are there for it to be working, then you have to revise what you said previously, right? So you're bringing it back.
Yeah. How are they telling you? Zener can work like normal. Okay?
Right.
Oh, yeah, yeah.
If they not break down, okay, they can be working in like normal. So now, when you get a negative here, 5 volt, this is the ground, then the diode will be on normal.
Right, because 0 is higher than -5.
Exactly.
So, diode on, you have to draw battery substitute for the diode. And 0.5, 0.7 volt. So
the drop across the resistor is 4.3.
That's a good question.
Oh, minus.
Right there. So you have to do a little math, right? So it's gonna be
current I equal -5, right? Minus to minus 0.7. 4.3, right?
Right.
correct.
Divide 220. Okay. So basically the current will be go this way.
Right. Just like the diode is pointing because it's directly polarized. Okay, good.
The thing is, this is 0.7. So if you get a right formula, they will be this way. You can get minus 0.7 minus to -5. Okay, minus, you get 4.3. Okay. Try to understand the zener. Okay.
Right, and just like you said, it's gonna be flowing to the left because that's the order of which you were subtracting there. Okay, good.
And this diode acted like a normal.
Yes.
Okay, now you guys doing for me. Example number 6. To see who can get through this circuitry.
We can try. So I think first question should be V out.
Remove the diode first.
That's right. That's what I told you.
Okay.
You're working with the Gina. First thing you're supposed to be no Gina. What we out?
And no load resistor.
Right, no, don't say no load.
That's
Just
what
no Gina.
So it looks like we have enough volts here to polarize the Zener diode in its breakdown situation. So it's gonna be on in reverse.
Now, my question is,
V out is 24 volts.
The out is 12 volts.
no. Okay. Again. First thing, what I said, no Gina. What we out?
24 volts.
The out is gonna be approximately 12 volts for no Zener because this is a divider right here.
Perfect.
Maybe a little more than 12.
Okay, now, if no Gina, you get register R and RL. They will be calculated out by voltage divider. Okay, we can telling you.
Hey, Mr. Pham.
Just a minute. Suppose no Gina. Then V out equal 24 times RL divide R plus RL. What you get?
A little bit over 12.
Okay, let's see. I can do calculation. Okay,
12.25.
24. Okay. 470 plus 490 equal inverted times 24. Okay. Times 490. 12.25. Is it right?
Yes.
Yeah.
Okay. 12 point. Okay, now, so we come up with the Gina. Gina breakdown or not?
Yes.
Perfect.
Hey, Mr. Pham, I got a question.
Yeah, go ahead.
My only problem is when you read from the very beginning, it says, for the circuit shown, solve for no load, which means the load resistor is not there. Is that correct?
Yeah,
You are right.
you don't have a load, no problem.
And then, so since it doesn't have a load, the next thing you do is you take out the Zener diode and then find V out. Is that correct?
You are
But
right.
you cannot remove the load.
No. Listen to what I'm saying.
The question is two parts.
Wait a
Yeah,
minute. Yeah. The first thing you do is take the load out because it says no load.
Don't take the load out. How come you get the load? You take it out.
Professor, I think for the sake of analysis here, this question is made a little bit introductory for the first three sub-questions it's asking without the load. and then it says go and put the load and then do all that same stuff.
Now, you see that one, you don't have any load. You see that?
So you're saying the one that we're talking about, you do it just like the one you just showed?
No, I said you remove the zener. That
I know, but
also-
Mr. Pham, listen, my question is, we take the load out first, because the load is on the schematic.
What do you mean? If you did see this circuitry, you get a load, right?
Okay, yeah, in other words, get rid of the 490 resistor.
Right here.
Yeah, take that out.
You cannot. How come you take it out?
Because your thing says for the
No,
circuit.
I not say take the load out. You see on this problem, the thing that they have a no load.
I know, but we're on a different one though, Mr. Pham.
That's a different one circuitry.
Right.
Okay, but this one is you get a load, you cannot move the load.
Well, why did you put the solve for no load for no load?
This is a no load here, right?
No, not that one. The other one down the bottom.
We are good, Professor. I think your question has two parts.
So okay, I see what he said. I'm not reading that.
Yeah, that's what I'm talking about. That it says no load.
For the circuit cell, shown for no load.
Right. So you take the load out.
Okay.
And then after you take the load out, the next thing is you take out the Zener diode.
Right.
And then you look for V out.
Right.
Okay, that's what I'm saying. So
Yeah.
now that you've seen the no load, now go back and do it again.
Right. This is another one right here. I say with the load. Okay. Sorry.
Okay, so start from the top.
Right. So with the no load, what we are equal? If you have a no zener,
is equal to 24 volts.
Right.
Perfect.
That's what I've been saying the whole time.
All right. We are good. We are back on the same page.
Okay.
Now go ahead, Mr. Pham, go ahead.
So no load. Okay. Zener out. V out. 24 volt. Okay. V out 24 volt. That means higher than zener voltage. Okay.
Right.
V zener. 12 volt. Then zener breakdown.
Right.
V out equal 12 volt. Okay.
How much is IL when there is no load?
So IL will be equal 24 minus 12. Okay. Divide 490.
Well, we agreed that for this moment we have no load.
The Damn.
So I think the answer should be 0, and that
Yeah.
one that is on the
Okay,
screen
okay,
should
okay.
be IT and divided by 470.
Yeah, you're right.
It's 0.
No load.
Yeah.
IL 0.
Yeah, 0. No load.
IG.
Okay, IZ in this case is equal to IT because there is no IL. And that is what you wrote earlier. That is 24 minus 12 divided by 470 ohms.
Perfect. Okay. Equal 24, right? Minus 12.
Well,
Divide 470. Okay. And what V out?
You already agreed that the Zener is giving it 12 volts.
it's in breakdown.
Yeah.
Right.
Try to understand, okay? We'll go very slow. Now, last one. With the load.
We're back at the beginning.
Okay, so with the load IL equal.
Now, Mr. Pham, I got a question before you do anything. Do you, okay, now we put the load in the circuit. Do we still go back to the beginning where we take the Zener out and then try to find out?
Right.
Okay, so we got the load in, and you take the Zener out, and then you need to know V out.
Right.
Okay.
So with the load.
You know what the answer to your question is? Depends on how much current the load will pull. If it pulls too much current, then it's going to drop the voltage on the Zener cathode, and if it drops below 12 volts, then you are in trouble.
Okay. With the load. So without Zener. V out equal 24 times IL divide R plus IL equal 12 point, I think 25, right?
Yeah, it's
Correct.
12.25. Yeah.
Okay. Okay. Now, come up with Zener breakdown or no?
Yeah.
Yeah, because 12.2 is higher than 12, and it can't,
Okay.
yeah.
So Joseph,
Yeah.
if this resistor RL 490 it was smaller than 470, try to draw that and see what you get. Just FYI.
Okay. Zener breakdown, then telling you V out equal
12.
12 volt. Okay. They want IL. That's easy. Okay. IL will be 12 divided 490. And IG Okay, so basically the current flowing here, IL you already get, okay, and the current flowing here. You
Right.
can see that current will be 24 minus.
Oh, you don't round it?
So the key thing here is the total current divides into Zener and the load current. So two of them, they give the total, right? So
Right.
if you know the total and you know the load current, then you know Zener indirectly because you
Okay.
subtract.
Yes. I total equal 24 minus 12. Point two. No, 12 volt. Okay.
Hey, can you write that
Aye.
down, Mr. Pam? Oh, there you go.
470. Okay. If you get IG, you take I total minus IL. Okay. Any question about this problem?
But when we have to round, because when you do the calculation, it's actually two, to 0.244. So we have to round it up because the extra number, the third number or the fourth number was 8. So wouldn't that be 25 volts if we're rounding it?
Which one?
Okay, I'm not doing calculation. I just get into the answer. I just telling you, like you want I total. I said you take 24 minus 12, divide 470. Is it right or wrong? If you say not right, let me know.
That's correct, yeah.
Yeah, it's correct.
Okay, you get the I total. Okay,
Right.
I total. They go up to here, one go here, one go here, right?
Correct.
So you already calculate the IL. That's why you can calculate the IG.
What's your question, Juan?
Yeah. You
Well,
get a
my
question? Go ahead.
Yeah, well, my question is just when we divide 12 divided by 470, we get 0.0255. When we have to round that up to a higher number.
That's a different topic, I think, and that is how you round the number. So I think you do 1, 2, or 3 significant digits. So that's a different topic.
Okay.
You can find me in the class, I'll explain it to you as much as I know.
Okay. The thing is the calculation, your guy can calculate it. Okay. This one, we don't asking you, is it we get ampere or milliampere or microampere? That's a difference. Okay, quickly. Here. You get the input signal here. Sideways. Positive 5, negative -5. Apply to this circuitry. Okay. First thing we're talking about positive first. Okay. Positive 5 volt. Okay. So basically, you can see the signal is 3 volt. So the signal breakdown or no?
Yes, it break down.
Perfect. Okay, if they break down, that means this signal, okay, they coming out, they go up to only 3 volt, not 5. However, you understand this one here, you see that? VG, 3 volt. So they cut it off. Okay? And now, when you go to the negative, okay, so you get a negative here. What happened? Gina,
It becomes directly polarized like the normal diode. That's why you have minus 0.7 here as the limit.
okay. So if you get a negative 5 right here, right? This is a positive. So the
You
signal
actually,
will be on normal. Correct? Gina, on normal. Okay? In order to know the V out, I'm telling you every time, if you say diode on or off, you have to draw substitute by the battery. Okay? This battery will be look like positive, negative. Zero point 7. So that's why you're looking in the output here, you can see that they will be minus 0.7. Okay, you get any question? So that's why I'm telling you, you want to be a technician, then you have to be in the meeting and you have to watch the video later on. Make sure everything clear to you.
just wanted to say something here on this term. So we're talking about inner on normal and breakdown. So that is only partially true here, because when you have your output follow the sinus signal, that's the time when Zener is actually not on. So only in the flat area on the left side here, it's actually breakdown, and in the flat area on the right side, it is in normal mode. The rest of times it is off.
Okay, on the left side, they break down, right?
Right, but only when it's higher than 3 volts. If it's between 0 and 3, then the diode is not operating.
What you said, when they higher than 3.
When higher than 3, that's why we have it cut off here on V
Right.
out, it's flat, right?
That's why they already cut it off at 3.
Right, but what about between 0 and 3?
What do you mean 0?
The sinus, it goes
No, they
from,
cut it off.
right,
You
right.
see it.
No problem, just trying to say something that's still here in our view, and it should be said, that's all.
The thing is when you connect into the circuitry, then you can see they will be exactly the same thing here. Okay? And when you get the negative peak voltage, then the Zener will be on normal.
Right,
That's why you get negative 0.7.
right. So Zener works when the line is flat on the outside, but when the line is curved, then it doesn't work. So there are times where it doesn't work.
Which one it doesn't work?
Zener is not working when the voltage on the inside is between minus 0.7 and 3 volts. It is just sitting there and not doing anything.
Right, you get only that one. The thing is when you get a DC here, okay, you cannot see that one.
Okay, I don't want to, I don't want to slow you down, just saying something that, I thought simple.
And after you understand on the first example here, that is the second one. They will be the same thing. Okay? Only they changing the diode. That going up, that going down. Okay? So that's why you get negative here, a positive here, and you get negative 3 volt.
So the batteries flip.
Okay,
Right.
on that one. Basically, on positive, one diode on. Okay, so you get 3. Okay, on the negative, another diode on. You get minus VG, minus 0.7. Okay, the thing is, at the output, you can get the signal, and also you can get the DC voltage of the diode. Okay, when you do in your lab, then you can understand that will be the same thing. Okay, only they changing different VG. Okay, if you want, you can do it easier using MSIM7. Okay, they will be so the output will be look like. Okay, we don't want to go into too many here. That's just a confused. Okay, and didn't have anything. This is a LED. You see everything. Okay, LED you can see on your watch. Okay, your cell phone. They display the number, the letter, whatever. That's what they're using. LED. Okay, and this is a 7 segment. You get each segment here, one diode. Okay, 1, 2, 3, 4, 5, 6, 7, 8 diode. Okay, so if you want to see the letter A, then you can see they end on this line, they on this line, on this line. So that's why you get letter A. You get number 9. So this on, this on, this on, this on, this on number 9. Okay, so that will be 7 segments. Now, rectify. You can see this is a sideway. They go to the rectify circuitry. Then now you can see what the difference. That will be telling you only positive so, not negative. Okay? That's why they call a halfway rectifier. What that mean halfway? The sine wave will be the whole sine wave. However, they converting only positive, not negative. That's why they call halfway. If they converting both positive, negative, and they will be full wave rectified. You see on the quiz we're talking about rectification. Okay, that means they converting this signal into this signal here. Okay, inside here, I guarantee you get just a diode. The thing a diode allow positive go, but not a negative. Okay, so that's why you can get only positive, not negative. What we call a halfway.
So,
Yeah.
for example, like the rectifier on a laptop, it can read, it does well reading a half wave like this, or do they smooth out the wave using other rectification?
No.
Like our electronics can work with a half wave of DC voltage like that?
Okay, depending on. Okay. However, this just telling you what that means halfway. You get the full sine wave. However,
Oh, yeah. Mhm.
when you go to the output of the rectifier, you get only positive, or you can get only negative.
Right.
However, if you want more, they will be show you later here. Okay.
Oh, there you go. Okay.
Okay. Now, halfway rectified. You can see this is the signal. So when they go into that one, you can see they can get just a halfway. Okay. Then they go to the filter. Okay. And you can see when they go to the filter here, okay, they get the volt DC. However, on the top, they get a ripple. Okay. Ripple means this is the noise. We don't want it. Okay. Then they go to the regulator. Now you can get the normally DC, no ripple. Okay. Complete power supply with rectify and filter and regulator. That means on the inside the power supply, you get the signal sideway coming in, and you get the filter. Then after the filter, you get the noise, ripple, and you need to go to the circuitry regulator. They will be try to cancel ripple here, so you get a DC voltage.
Hey, Mr. Pham, when they say ripple, that's it. When they say AC riding on DC, is that what they mean?
Right.
AC riding on DC.
Right.
Okay, thank you.
That's just a noise.
Correct.
And the noise, that means the unwanted signal.
Unwanted signal.
Okay, halfway rectified circuitry. And now they given you more detail. Okay, you get the sine wave here. And they go through the diode. And they will be rectified on the positive and the negative, nothing, just positive. Halfway rectifier. And from here to here. Okay. Period. Frequency out. Frequency in the same. Taken approximation. V peak out equal V peak in minus 0.7. You know why? How? Why that one? The thing is,
You're using a diode.
you get the sine wave coming in. Okay? The diode will be on, right? So the signal coming out, you can see here, right? So if the diode on, again, I'm telling you, you must be substitute diode by the battery. So this is the battery, positive here, negative here, plus, minus 0.7 volt. Okay, so this one they draw for ideal diode, so you don't see. But later on, you can see the signal basically they get the output will be DC will be right here, minus 0.7. And the voltage now they different. They will be go this way. Okay, so the V peak now is not the same like this one. Why? The thing is they put it out. So V peak have to be equal the input minus 0.7. Okay. Next transformer. This is a transformer. Transform from one voltage to the other. Okay. Transform 1 voltage to the other. That one they call a primary voltage. That one is secondary voltage. Okay. And also you see NP, NA. That means just the wiring make how many turn to make that primary voltage VP, secondary VS, NP. Number of turn in primary and at with number of turn in secondary. How many wire turn they make it. And they get formula NP over NS equal VP over VS. Then you can calculate the VS by this formula. Okay. If NS more than NP, transformer will be step up, and NS less than NP, step down. Now, try to understand step up, step down. You can see at the school, you see outside they get the power line, okay, 400 volt. However, when they go to the building, they going down to 110, 20 volt. They have to get the transformer. Then transformer will be step down. Okay? If the VP, okay, step up means V S higher than VP. Step down, that means VS less than VP. That's a very general about the transformer. If you need transformer, you just using this formula.
And VP comes from the outside power line, right?
Right. Okay, now halfway rectified. Okay. In this circuitry, okay, if the circuit show determine, for the circuit show, determine peak secondary voltage VP. Okay. Now you get the transformer. you get 2 to 1. That means NP equal 2.
So that means the secondary voltage
78
peak
volts.
is gonna, yes, half of the,
NP equal 2. And add 1. Okay. And now they say pick secondary voltage. Okay. This is a secondary here. Okay, this is VP. So you want the second. You can using the formula here. VS and S time VP. Let's see, VS equal NS time VP. Divide NP. That's VP, sorry. Okay, just apply the formula. Okay, the rectified peak output VP. Okay, that means they want the signal at the output here. Remember, Zener will be, diode will be on. So you can substitute battery plus minus 0.7. So at the output, you can see if this is 0. Okay. Then you get DC will be here minus 0.7. Okay. And the signal they coming out, they will be look like. Okay. If input frequency 1K, what is the frequency out? Everything we already telling you in here. Okay. You need to looking into that. They telling you. Okay. F out, frequency out equal frequency in. Now, full wave rectifier. They're using the transformer. But the transformer, this transformer different from the other one. You see, in the middle here, they routed. This is what they call a center tap transformer. Okay, this transformer cost a lot of money. You just learn to know, but they never use. The thing it cost too much. And this circuitry they call a full wave rectify. Again, I telling you, this is the input here. You get positive, you get negative. Last time, when they go to the halfway rectify, you see only positive, not negative. Okay? However, on this transformer, they show both positive and negative. That's why they name full wave rectifier. Okay? And they say the DC average VDC output will be 2 times VP divided 6.284. Frequency out equal to 2 times V in. If you get a 1 kilohertz in, output will be 2. Ideal diode will be 0 volt. Okay, but we're not using ideal. We're using practical diode. Same thing. We already said 0.7 volt. Okay, and you can see the V out, V peak out equal V peak in minus 0.7. That's what I'm telling you.
Hey, Mr. Fan, what was that FIN?
What?
FIN, where it says F out equal to FN? Oh, the frequency out.
Frequency.
Frequency, yeah. Okay, frequency out equal twice.
That's what I already telling you.
Yeah, I got it.
1 kilohertz input signal. You get.
So the output is 2K.
Yeah. Okay. These are just a little more try to explain in more detail. If you get the time you want to learn more, okay, you can looking into this circuitry. Same thing, okay?
Yeah.
Still the same thing, okay? I try to bring it out for you guys. If you get the time you want to know more, and you can see that, okay? And also in here, for more detailed calculation, okay? Basically, we don't care much. Only sometimes I can asking you, okay, what the V pick here. This just using the formula. You can calculate it. Okay, this is just an example. And this is the answer. Okay, you can look into that. Now, next one. Bridge rectifier. That means the same thing like a transformer. Same thing like this circuitry. They work exactly the same. Basically, full way rectify. They rectify positive, rectify negative. They using only 4 diodes. So you can see they never using the transformer. Center tap got too much. They using this circuitry. Diode maybe 25 cents for 1 diode. You see that? So this is the circuitry. More will be using. Okay. You can get a one simulation MSIM7 working with this circuitry. Okay. That means they will be either this red and red will be on, or blue and blue will be on. Okay. I see. Now they go detail here. Bridge rectifier. During the positive half cycle. That means here. Okay. D1, D2. This is D1, D2. Okay, D1, D2. Now, if the input coming in here, I just given you a little explain right here. This is the positive, okay? And basically, if you get a positive on this side, then you will be get a negative on the other side. Okay? They will be opposite. So my question is, when you get a positive here, which diode will be on?
Where?
You get a positive
Okay.
here.
Then it's gotta be D1 is gonna be on. Mhm.
Positive here. This will be round, right? So D1 will be on. Okay?
Right, and one question, so in that situation, the bottom of the transformer will be negative, right?
You mean on the primary
On the secondary of the transformer, is it
thing? They get a positive.
right? But is the
They get
bottom
negative.
right? So compared to the ground, is the bottom of the transformer more negative than the ground? It is, right?
First thing, I said D1 on. You know how, right?
Right.
You get positive and this is around. They on. How come D2? You understand it in this case. D2 will be negative, right?
That's what I'm asking for more
Right.
information.
You
Okay.
round here.
Right, right, right.
Negative. So D2 will be on. Okay? They will be on either D1 and D2 or D3 and D4. So when you get a negative on this side, okay? So basically, now negative. Negative on this side, then the other side have to be opposite, positive. On that side now will be positive. Okay, so if you get a negative on this side here, and this side will be round, D3 will be on. Okay, and when you get a positive on this side, this will be round, D4 will be on. Okay, so that will be telling you two diodes will be on. Only thing you have to know which diode will be on. Okay, and this is a more detail. Okay, they explain to you. So that's why either D1, D2, or D3, D4 on. You can get the output will be full wave rectified, working like the other one, full wave rectified. Okay, and just a more detail telling you what formula you need. If you need to calculate output, you can using the formula. Okay. Now, capacitor input filter. Now connect the power filter here. The capacitor. Okay. Initially charging of the capacitor diode forward bias happen only once when the power in is turned on. So basically, when you just turn on, gap apply the power. Okay, capacitor will be charging. Capacitor 0, and they charging up to the voltage peak in here. Okay, that's what they're using for filter. For later, more stable signal. Okay, this one just a detail for you. Okay. Filter will be keep charging. Then when they negative, they discharge, and when they positive, they charge again. Okay. So you can see capacitor input here. Okay. First thing they charging. Okay. They discharge, then they charging. Charging and discharge. Basically, this is not good like that one. Okay. When they full charge, that means they will be a DC. And whatever here, they call a ripple. That's just a noise. Okay. That's just ripple here. See that?
How could that, like in real life, affect electronics if you have a lot of noise or
No. The thing is, you want DC signal coming in. Okay. So without a capacitor, you cannot get DC. The thing is DC will be keep charging. Okay. The good one, that means you get just a little signal here, little ripple. Okay. And that will be a DC. Okay. The thing is when DC charging, full charge, they will be a DC. Okay. They will be a stable. Okay. So what I can do, okay, is make sure you get the time. Okay. Then you try to reading the handout. Okay. But the handout basically too much. And you can watch the video. Okay. After we stop today, I try to upload it tonight. Okay. And you can watch it again. And also, again, I'm telling you, if you want to really understand it, you have to reading handout over, up to the certain point, and you don't have to memorize. Okay? That's what my experience. Okay, when I learned it. Okay.
Read the handout 1,000 times.
Exactly. Like later on, you will be learn the software. Okay. Program. Everything will be right at the beginning. Okay. Cannot understand. However, if you're reading over and over, guarantee you can understand at a certain point you never know. Okay. You understand, I've been working after about, 10 years. And now they've given me a project using the software learning C++. I don't understand what C++. That's a 1990. However, I go to the school in the La Jolla, 1,500 for 1 week. But my company pay for me. After a week, they talking about a whole book, and you cannot understand either. However, I cannot get the project done. They lay me off. So that's why I keep reading the book. I get too many different books. I bought it. I read over. up to a certain point, I understand everything. I don't know how. I don't know why. Okay? So
It's
one
called
thing
an
to learn.
epiphany. You had
Yeah.
an epiphany.
Yeah, one thing to learn. Keep reading. They go to your brain. You never know. Okay? That's what,
Yes, sir. I try, sir. Thank you.
yeah, that's what my experience. I try to helping your guy. You don't understand. Yesterday, one combination email to me. They want to, I introduced to them one very good technician in the program. But up to that point, I get that one in touch you. He okay, he good to me, but the thing is, for some reason, with the problem, so that's why he said he have to wait until the next one. I don't know. However, I want training you to be a technician or be an engineer, depending how much you can get from this program. Okay? So, any question?
Good job, Mr. Pham. Step up, not step down.
So, Mr. Smith, now you understand more, right?
I step up.
Yeah, I understand a little bit more, Mr. Pham.
Okay, so I hope you guys get a very good holiday, long weekend, right? 4 days.
Thank you a lot, Mr. Pham. Thank
Oh
you very
yeah.
much. Good night.
Okay,
you.
good night. Good night,
Thank you,
everyone.
sir.
so much.
Give us Pam.
Thank you, sir.
Good
Thank you
night.
so much. Good night, sir.
Bye.
All right.